Hey, in this section we're talking about the product rule, the quotient rule, and the power rule. The product rule says this: if you have the log of a product, you're going to break that into the log base b of m and the log base b of n, all on the same level. But the rule says when you multiply the terms, you add the logs. Now, you've done this before. Think about it. A long time ago, you might have had a problem that looked like this: x to the third times x to the fifth. And your rule was when you're multiplying with like bases, you add the exponents. Remember how logs and exponents go hand in hand? Well, the same thing is going to be true here with these logs. When you're multiplying the terms, you add the exponents. Both are increasing functions. Now, let me show you the other one. The other one says if you have the log of a quotient, m over n, you're going to take the log base b of m and you're going to take the log base b of n. Notice that they're all on one line. The rule says when you're dividing the terms, you subtract the logs. Both are decreasing functions. So when you're dividing the terms, you subtract the logs. The last one is the power rule, and it says if you have the log base b of m to some power, what you can do is bring this power out in front. And that is called your power rule. In this section, we're going to expand and condense logarithms. So right here, I ask you to expand each log expression. This top one here uses the power rule. So I'm going to take this 4 and bring it out in front. So it would be 4 log base a of x. Please notice that the a is by the g's tail. It is not with the x. Okay, let's look at the second one. With the second one, I see two terms. So I'm going to take a log base a with both terms. So it would be log base a of 76 and log base a of 13. Please notice that the a is by the g's tail. The rule says when you divide the terms, you subtract the logs. So this whole expression here is your answer. That's what I'm looking for. When you divide the terms, you subtract the logs. Whew, and we jump straight to a bad one. So here's our next one. This is definitely the hardest one that you would see. First of all, you have to clean up the radical. So you have the log base c of y cubed, z squared, and x to the fourth. Now all of those are underneath the radical, so I have to rewrite that radical. Remember, it's understood to be a 2. Well, when you rewrite these exponents, a 2 goes in the bottom. So this one's under a radical 2, and this one's under a radical 2, and this one's under a radical 2. Remember that a radical means fractional exponent, so that 2 goes at the bottom of each fractional exponent. Now, let's clean up that expression. It's the log base c of y to the 3 halves. That doesn't simplify. Z to the 1 and x squared. Now, that's not our answer. My directions said expand the expression. When you expand the expression, you see that you have a y, a z, and an x. So that means you need 3 logs. So you need a log for the y term, and you need a log for the z term, and you need a log for the x term. So first you get rid of the radical. Now you can expand it. When you expand it, they will all be on one line. Now look at the top. I'm multiplying the y and the z, so that means I add their logs. I'm dividing by x squared, so that means I subtract its log. Okay, that's still not our answer. We have one more step. So remember, the last step is to bring your powers out in front. The z doesn't have a power, so we'll leave it alone. So my answer would be 3/2 log base c of y plus log base c of z minus 2 log base c of x. Please make sure your c is by the g's tail. Do not write cy, cz, cx. The c is by the g's tail. So you'll say, well, that's a lot of stuff up there. What's our answer? This entire green statement here is your answer. You have expanded the log expression. I thought we were done, but we have one more of these to do, and then we'll shift gears a little. So let's do one more. The directions are still to expand the log expression. When we get ready to work this one, I notice we have two pieces. So I'm going to have the log base 5 of 125, and I'm going to have the log base 5 of y. I notice that I am dividing the terms. Dividing the terms means subtracting the logs. Now, this one's interesting. We haven't done this one like this before. Prior to this one, let me actually flip back a slide or two. We had base A, x, base A and a number, base A. We had base C, base C, base C. Nothing simplified because we had letters in the bases. But if you look at this one, you've seen a problem like this before. Look at just this piece. See how you have a 5 here? See how you have a 5 here and a number here? Well, with two numbers there, you can actually simplify it. And we've worked on this earlier in the section. I can ask you this question. 5 to what power? 5 to what power is 125? Okay, let's think of it for a second. 5 to the 1 is 5. That doesn't work. 5 to the 2 is 25. That doesn't work. 5 to the 3 is 125. That's it. 5 to the 3 is 125. So this would be 3 minus the log base 5 of y. And that's your answer for that one.